Hello everyone, my name is Priyanka and I welcome you all to my session. So let's just directly jump on our question, which says that in a meter bridge, the balance point is found at a distance L1 with resistances R and S as shown in the figure. An unknown resistance X is now connected in parallel to the resistance S and the balance point is found at a distance L2. Obtain a formula for X in terms of L1, L2 and S. Alright, so a slide wire bridge is also known as meter bridge and it is constructed on the principle of Wheatstone bridge and it is used to find the resistance of an unknown conductor. When the jockey is moved along the wire, there is one position where the galvanometer will show no current. Then a meter bridge is balanced and the balance condition is written as R upon S is equal to L upon 100 minus L. Now let's come to our question where R and S are connected. The balance point is found at a distance L1. So we can simply write that R upon S is equal to L1 upon 100 minus L1. So what we can do is that we'll just name this equation as 1. Now what is happening is that an unknown resistance X is getting connected in parallel with this S. So can we say now that S1 is equal to Sx upon S plus X? How? It's just a resultant of the two resistance when they are connected in parallel. And the balance point is now obtained at the length L2. That means R upon S1 is equal to L2 upon 100 minus L2. So let's just put in the value of this S1 into this equation. So R upon Sx, so the denominator will go up, S plus X is equal to L2 of 100 minus L2. Okay, so let's just name this as equation 2. So now what we are supposed to do is that we are going to divide equation 2 by equation 1. That means let's just directly put it that this was our equation 2. So we're going to divide it by equation 1. So it was R of S and it was L1 upon 100 minus L1. So here we can see that this R is getting cancelled and this S is getting cancelled. So directly what we can get now is that S plus X upon X is equal to L2 upon L1 and it is 100 minus L1 and it is 100 minus L2. Now this LHS can be written as S plus X plus 1 is equal to L2 100 minus L1 and it was L1 100 minus L2. So now we're just going to take this 1 on the other side. So L2 100 minus L1 is equal to L1 100 minus L2 and that's minus 1. So see, now we can take up the LCM and so what will happen is that minus L1 100 minus L2 upon L1 100 minus L2. So now we just left with the job of opening the brackets. So it can be written as 100 L2 minus L1 L2 minus 100 L1, and it is plus L1 L2, and here we are having denominator L1 and 100 minus L2. So we can see here that this is getting cancelled, and then 100 we can take common, so 100 L2 minus L1, and then L1 100 minus L2. So it was S upon X. So let's just reciprocate it so that we can just get our answer in terms of X, which can just be written as L2 100 minus L2, L1 100 minus L2 upon hundred L2 minus L1 into S. So that's our X in terms of S, L1 and L2. So see, in this question it was looking very complicated, but here it's just two fundamentals that was used. That was the concept of Wheatstone bridge, that is the balance point condition, and then it was just simple mathematics that we were using here. So nothing to worry about, just concentrate on what is given in the question and then follow a step-by-step procedure, and everything gets easier. I hope there's no doubt any further in this question. Thank you so much for your time. Bye-bye.